So we are going to start October-November 2021 paper 4-2. Let's start with question number 1. Radium is a group 2 element. The predicted lattice energy of radium sulfide RAS is minus 2612 kilojoule per mole. Define the lattice energy. So you may remember the definition. It is the enthalpy change when 1 mole of an ionic solid is formed from its compound under standard conditions. Is this clear to everyone? Now, some data relating to radium and sulfur are listed. Select relevant data from this list for use in your answers to parts B to E. Okay. So in part B, write an equation for the process corresponding to the second electron affinity of sulfur, include state symbols. So if you recall, the first electron affinity would be when a gaseous atom gains an electron and form a gaseous ion, 1 mole gaseous ion with a -1 charge. That is first electron affinity. So in the same way, when this -1 gaseous ion gains 1 mole of electron and form 1 mole of gaseous -2 ion, then the energy change for this gain of electron is actually the second electron affinity. So you have to write this expression over here, starting from sulfur -1 gaseous ion 1 mole plus 1 mole of electrons, arrow sulfur -2 gaseous ion 1 mole. Is this understandable to everyone?
ऊपर जो आपने डेफिनेशन लिखी है उसमें ये नहीं है फॉर्म इट्स गैसियस आयन.
Oh, sorry. Yeah. Thank you, Halima. I just mixed up. From its gaseous sign, yeah. It is always when gaseous ions form an ionic solid, 1 mole of ionic solid under standard conditions. Thank you. Okay. Now, sulfur exists as S8 molecule in the solid state. Use the data in this question to calculate the enthalpy change of the reaction of S8 solid turning into 8 moles of sulfur gas. Okay. So actually, this question is not as simple as the other lattice energy questions. Okay. So have a look over here. If you look at this equation, in this equation, 1 mole of sulfur solid, no, sorry, 1/8 mole of sulfur gaining 2 electrons, forming 1 mole of sulfide ion that have a 2- charge. So if you look at this equation, we have a solid over here, right? And we have a gaseous ion over here. And its energy change is positive 55. So basically, this equation is actually showing two different energy changes. One is atomization.
Atomization and
Yeah.
electron affinity.
Yeah, very good. And electron affinity, and both the electron affinities. First electron affinity and second electron affinity, and the sum of these is positive 55, positive 555 kilojoule per mole. Is this understandable?
Yes, sir.
Yes, if anybody have any confusion, do ask. Now, if you see what they are asking for, they are asking for that we have a 1 mole of a sulfur and it is turning into 8 moles of sulfur gaseous atoms. And I have to find its enthalpy change, right? So if I split the first equation, this one, so I can write it in this way, that 1/8 moles of sulfur first actually turns into 1 mole of sulfur gas, and this change is considered as atomization, and then it gains 1 electron as a result. It turns into sulfur -1 gaseous sign, which is the first electron affinity. And if you look in the table above, here you are provided with the first electron affinity of sulfur, which is -200. So here the energy change is -200, right? And when this gains another mole of electron, it would become sulfur S-2 gaseous ion, and that is the second electron affinity. And here there is a value for the second electron affinity of sulfur, which is positive 532. And I don't know this, so I can mark it as a X. And from the first equation, what I have concluded that basically the sum of this is actually equals to positive 555, right? So if I would subtract these two values from 555, so I would get the atomization when 1 mole of sulfur is being formed. So if I would find X, it would be 555 minus 200 and minus 532. So can anybody solve me and tell me what we are getting over here? Yes.
Sir, minus 1.1 exponent 3.
Beta, calculate it again. How it cannot be exponent 3.
Wait, 223.
Sir, sorry. मेरा गलत आ रहा है.
223. So it means that this x over here is 223. Now, if you multiply this equation by 8, you would get S8 because the 8 in the numerator and the 8 in the denominator would cancel out. So I would just get 1 mole of sulfur turning into 8 moles of sulfur gas, which is actually same as this equation. So if I multiply this by 8, then I would multiply its enthalpy change by 8 as well. So its enthalpy change would be 8 times 223. So can anybody tell me the answer?
1780.
17.
84.
1784. So the enthalpy change of this conversion of sulfur molecule into 8 moles of sulfur atom would be positive 1784 kilojoules per mole. Is this understandable to everyone? If anyone have any confusion, do ask. Okay. Now, in the D part, they are asking you to calculate the standard enthalpy change of formation of radium sulfide. So if you recall the expression for the standard enthalpy change of formation, we have decided that it is equals to lattice energy of radium sulfide plus atomization of radium sulfide plus atomization of radium, then sum of ionization energies of radium, because radium is going to be forming a cation, then atomization of sulfur, and the sum of electron affinities of sulfur, as sulfur is going to become an anion. So if you look in the table, the lattice energy of radium sulfide is given over here, which is minus 2612. So the enthalpy change of formation is equals to minus 2612, which is referring to this enthalpy change. Then if you look over here at this equation, again, if you see there is a solid, there is a gaseous ion. So it means this value is basically the atomization of radium. And as I am getting the two positive radium ion, which means that the sum of ionization energies of radium, and it is positive 619. So I would put a positive 619 over here, which is actually referring to these two enthalpy changes. And then we discussed this value earlier, that if you look at the equation, first, that the 1/8 mole of a sulfur molecule turns into 1 mole of a sulfur gaseous atom, and then the electrons are being added to form a S2 negative ion, which means this enthalpy change refers to atomization of sulfur and then sum of electron affinities of sulfur, which is positive 555. So I would write 555 over here. 1 minute. So here I have a 1619, which is referring to these two enthalpy change, and then 555, which is referring to these two enthalpy change. So if I would add, I would get the enthalpy change of formation. This, can anybody tell me the answer?
Negative 438.
Negative 432, right?
No, 8 instead of 2.
Okay, sorry. 438. Is this clear to everyone? Okay. State two major factors that affect the numerical magnitude of lattice energy. So if you recall, the factors that can affect the value of the lattice energy is actually the ionic radius, and the second one is the ionic charge. The more the ionic radius, the smaller the lattice energy, the greater the ionic charge, the greater the lattice energy value. So these are the two factors. Next part. For each factor you have identified in E1, state whether it tends to make the lattice energy of radium sulfide more or less exothermic than that of sodium chloride. Okay. For that, you have to refer to the periodic table to see their positions. So if we look into group 1, in group 1, you would find lithium, that is a period 2, 3, 4, and sodium over here. Then afterwards, sodium, we have potassium, rubidium, cesium, and francium in period 7. And if you look in group 2, here I have a beryllium, magnesium, calcium, strontium, barium, radium. So for the cations, I have to refer this sodium and radium. I have to relate these two. So as it's in group 1, so sodium ion have a positive 1 charge. As it is in group 2, so our radium have a 2 positive charge. Now the next element that we have a sulfide is from group 6 or group 16, and it's in the period 2 we have oxygen, and in period 3 I have a sulfur. Then the next element is from group 17. The first element is fluorine and the second element is chlorine. So I have to relate these two. It have a 2 minus charge and it have a 1 minus charge. Okay. Now, if you look at sodium, as when the sodium becomes its ion, it have a 2 shells. So for example, if its ionic size would be this, if you look at radium 2 positive, although its charges are bigger, but it have a 6 shells, which means that its size would be very much greater than the sodium. So obviously, if its size is very much greater than the sodium, which means its charge density would be very less. So the lattice energy becomes less exothermic. Is this clear? So for the ionic radius, I can say that the lattice energy of radium sulfide less exothermic, means the attractive forces are weaker, so less energy is released. Bonds formed would be weaker, as radium 2 positive is very big than Na positive. Now, if I compare these two ions, that the sulfide ion and the chloride ion, sulfide ion have a 2 negative charge, which means it have a 2 extra electrons. So it have a little bigger ionic radius than the chloride ion. Chloride ion have a little smaller radius than the sulfide ion. So as the size gets no, 1 minute. Just give me a minute, please. Yes. So here in this case, when I compare these two, the difference in size is not significant because the sulfide have a bigger charge. So I can write over here as sulfide have greater charge then chloride. So the lattice energy of radium sulfide would be more exothermic Is this point is clear to everyone? Okay. Next part.
Sir, more highly charged ions will make it less exothermic, yes?
Why? If the charge is high, then isn't it had a more attraction?
Oh, yes, right.
If there is a more attraction, the attraction would be stronger. So the bond made would be stronger and more energy is released.
Hmm.
The lattice energies of sodium chloride and radium sulfide are -771 kilojoule per mole and -2612 kilojoule per mole respectively. Okay. Its lattice energy is -771 kilojoule per mole and its lattice energy is -2612 kilojoule per mole. Identify the dominant factor in determining the relative numerical magnitudes of the lattice energies of radium sulfide and sodium chloride. So, if you look at these, due to this double charge, it would become more exothermic. That's what we concluded. And here, if we are observing that its energy is more exothermic, right? And due to the bigger size, it's getting less exothermic, but in actual, it's not getting less exothermic. So it means as they asking which one is the dominant factor. So it means that this big size, sorry, is not dominating. But this greater charge is actually dominating. See, Mubashir, if it would be less exothermic, then here we don't get a greater value.
Yes.
So what is the dominant factor? So I can write over here that the ionic charge is the dominant factor because the lattice energy of radium sulfide is more exothermic than the lattice energy of sodium chloride. Is this understandable to everyone? Yes, if anyone have any doubt, kindly ask. Okay. Now, this is question number 2. Ethoxyethane, C2H5OC2H5 can dissolve in both water and in octane 1-ol. Okay. The expression and the numerical value for the partition coefficient of ethoxyethane between water and octane 1-ol are given. Water and octane 1-ol are immiscible. Okay. So here we have the partition coefficient value, which is 6.760 at 20 degrees Celsius. In an experiment, octane 1-ol at 20 degrees Celsius is added to a solution of ethoxyethane in water at 20 degrees Celsius. The mixture is analyzed immediately and the value of KPC is calculated. The calculation performed correctly, the value calculated is 5.625. Explain why the value calculated is less than 6.760. Yes, anyone want to comment on this? Yes, Halima, can you comment on this? Ahmad, Mubashir. Moiz, Reda, Soleha, Sania, Mubashir, Mariam. Okay. If you read this statement, what this statement is saying?
सर इसमें वाटर की
Yes.
कंसंट्रेशन इफेक्ट होगी.
No. Read this statement again, everyone. The mixture is analyzed immediately and the value of KPC is calculated. So on immediate calculation, we are getting this value. So what we can conclude from this information? Okay. If we if we analyzed it immediately, it means we didn't wait it for the equilibrium to be established, right? The equilibrium is actually not established and we have calculated, we have analyzed the mixture. And that's why we are getting the smaller value. Is this point is understandable? And from this, we can conclude that what you said, Soleha, see, the value is 6.760, which means that octanol is in denominator. So in actual, its concentration would be more in it and low in it. But here the value is smaller than this, which means that here it's low in octanol and high in water, which also indicating that the amount that have to be transferred or dissolved in octane 1-ol is not completed yet, and we have calculated this value. Yes, is this understandable? So we can write, as it's for 2 marks, so the first mark that the equilibrium is not established and the concentration of ethoxyethane in water is higher than then at equilibrium. Yes, is this understandable to everyone? If anybody have any confusion, kindly ask. Okay. A second experiment is performed and the value of KPC is found to be 6.760. The concentration of ethoxyethane in octane 1 all layer is 7.62 gram per dm cube. Calculate the concentration in gram per dm cube of ethoxyethane in aqueous layer. So we have a KPC expression over here. We would use this expression over here, that the value of KPC is 6.760 is equals to concentration of ethoxyethane in octane 1 all is provided to us, that is 7.62 gram per dm cube. So the concentration of ethoxyethane in water would be x gram per dm cube. So we have to find the x. So x is actually equals to 7.62 divided by 6.760. This, can anybody calculate and tell me the answer? Yes, please.
One point one two seven.
Yes, can you repeat?
1.127.
1.127. Okay. Now, 100 centimeter cube of octane 1 all layer is taken and shaken with 100 centimeter cube of water. Calculate the maximum amount in mole of ethoxyethane that can be extracted into water. Okay. Now, if you see what they are telling you, okay, we have a ethoxyethane in octane 1 all, and we have added water, and some of the ethoxyethane would transfer into that water, into that aqueous layer. So here, initially, I have 7.62 grams of ethoxyethane in octanol, right? And there must be 0 moles of ethoxyethanol in water initially. Then if I would look for a change, I can conclude that the change is X, that the X moles of ethoxyethane would be extracted from octane 1-ol and dissolved in water. So at equilibrium, the amount of ethoxyethane in octane 1-ol would be 7.62 minus X, and amount of ethoxyethane in aqueous layer would be X. Is this understandable to everyone? So I got the amount of ethoxyethane in both the layers at equilibrium. Now, if I use again the Kc expression, so the Kc value is 6.760. In the numerator, I have the concentration, according to the formula, I have the concentration of ethoxyethane in octanol, which would be 7.62 minus X, and the amount of ethanol in water would be X. Now, it can be okay, 1 minute. There is a mistake, a small mistake. Okay, just do it. Let me check. It would be 6.760. X is equals to 7.62 minus X. So if I shift this X over there, it would become 7.760 X is equals to 7.62. So X would be equal to 7.62 divided by 7.760. Yes, can anybody tell me the answer?
0.98, 0.982.
0.982.
0.982, yes.
0.982. So see over here, the value that we have used is a gram per dm cube. And here only 100 cm cube of these are used. So it's the grams in 1 decimeter cube, which means that this much grams are in 1000 centimeter cube. So, but here we have only 100 centimeter cube. So it would be X. So if you find X, you would find that it is 0.0982 grams. And here, if you see, they have asked you for the moles. So you have to divide it by the MR. So if you calculate the MR of this, it's C2 means 24 plus 5, 31. And 31 over here, 31 and 31 gives you 62. No, 24 and
74.
29 plus 16 plus 29, it's 74. Okay, so 74. So divided by 74 to convert into moles. So what is the answer?
0.0132, 0.0133.
0.0133 moles. So my answer over here would be 0.133 mole. Is this clear to everyone? Mubashir, can you calculate this again? Is it 0.0133 or is it 0.00133?
It's 0.00133.
Okay, thank you. It's 0.00133. Yes, yes, we have a 1 decimal over here, so it would be on greater. Is it clear to everyone? Okay. An aqueous solution of lead 2 nitrate is mixed with an aqueous solution of sodium iodide. Lead 2 nitrate is this and sodium iodide is this. A yellow precipitate of lead iodide is formed. So they have told you that when the lead iodide is formed, it is water insoluble. So you will get the yellow precipitates and is filtered out and leaving solution X. The concentration of lead ions in solution X is 5.68 mole per dmq, exponent minus 3 mole per dmq. The concentration of iodide ions in solution X is 4.2 exponent minus 4 mole per dmq. Use these data to calculate the value of the solubility product Ksp for the lead nitrate. So okay. So if I would make an equation, just let me make the equation. Okay, we have to find the lead iodide. Okay, so they have provided us the concentration. Okay, it's simple. So this is the concentration of lead ions in the solution, and this is the concentration of iodide ions. And the formula of lead iodide is PbI2. So if I would write the KSP expression would be concentration of lead ions raised to the power 1 as there is a 1 mole times concentration of iodide ions raised to the power 2 as there are 2 moles of iodide. So if I put the values over here, so the concentration of lead to positive ion would be 5.68 is 5.68 exponent minus 3, and the concentration of iodide ion is 4.20 exponent minus 4 square. Okay, let's work for the unit. Just calculate and tell me the answer. Mole per dmq times mole per dmq whole square. Okay, so if I multiply, it would be mole cube and dm minus 9. Yes, can anybody tell me the value of Ksp?
So 1 into 10 is to have minus 9.
1 is to 10 raised to the power minus 9. Okay. Is this clear to everyone?
Sir, 1 second. Can you go back to the previous question?
Yes.
The reason why it is not coming 00 is because you need to multiply the 7.62 divided by 1000 then into 1000. So you will get 0.762.
Here we did it.
No, like in the whole question, the 7.62 value will be 0.0762 because it's 100 centimeter cube.
Yeah, so I did it over here. See, I have find after doing this, I convert
Yes.
into with 100
Yes.
over here.
Yeah,
And
that's
if
why I didn't put it 0 here. That's why I got the wrong value. I understood now. Yeah.
Potassium iodide is very soluble in water. Describe and explain what is seen if a few drops of saturated potassium iodide solution were added to a portion of a solution X. Okay. What we have in X? In X, we have a lead ions and iodide ions in aqueous state. But if I add potassium iodide in it, what would happen? The concentration of iodide ion would increase, and as a result, that potassium iodide would precipitate out, and here they have told you that it shows yellow precipitate. So it shows you yellow precipitate. So that would be my observation. But there are 2 marks, and that is called common ion effect because there is a common ion over here in potassium iodide and in X both. So yellow precipitates are observed or are formed because of common ion effect caused by iodide ions. Is this clear? Yes. Okay, now here we have a question number 3. And from question number 3, we will start this question in our next class. And hopefully we will do our next class tomorrow. Okay. So see you everyone tomorrow. Take care everyone. Allah Hafiz.
Allah Hafiz, sir.